Hello everyone, I'm here with the 9-4 notes. I want to remind you that I started putting some of the keys to the homework so you can check your work and see how these are going as you try these assignments. Also remember, you got the choice. If you got a printer, you can print them out. Otherwise, feel free to just work out the problems on notebook paper. Alright, here we go. Rational exponents. So what we have now is there's a way to rewrite things with radicals with a variable within exponent that's a fraction. So what you can see here, the key is that the index, which is what's inside your square root, that becomes the denominator. And whatever power is on this variable, that's going to be your numerator. So starting out with this first example, originally it did not have the 2 there and the 1. I added those on. If you're just looking at it originally, it was just the square root of x. But there's a 2 here and a 1 there. And so when we rewrite this, this becomes x. This exponent becomes the numerator, 1, and the index here, the square root, that becomes the denominator. And that's how you rewrite your square root as a variable with an exponent. So example 2, again, we've got the hidden 1 here, so that 1 will become the numerator, and the 3 becomes the denominator. If you have a number in front, it just stays in front. We have a coefficient there of 2, so we just leave it alone. 4 becomes the denominator, 3 becomes the numerator. Just simply rewriting. If you have two variables inside, it's basically double trouble. We've got to do x to the power of, this becomes the numerator, 5/3. We've got the hidden 1, 1/3. Example 5, 10 stays in front. Again, now it's the hidden 2. 10 to the power of x to the first, so 1/2. Y to the first, 1/2. Once we've done that, we just learned how to basically reverse the process. So now we're going to take what originally would be called exponential form, and we're going to rewrite it in radical form. So just in reverse, now the denominator becomes the index, and the numerator becomes the exponent. So the cube root of x squared. The case again where we don't necessarily have to write the 2. Everybody just agrees throughout the world. If you see something with a radical, if there's no index, that index is agreed to be 2. Same thing, the exponent on x is 1, so it just becomes the square root of x. If you have the same denominator here, we can just put one radical with the 5 and put both of these inside. So x to the third, y to the second. Example 9 is showing you that if the denominators are different, then you're going to have two radicals. So for the 3 here, we get the cube root of x squared. But for the y to the 1/2, it needs to be its own separate radical, the square root of y. If you have parentheses, everything then in the parentheses is raised to the 3/4 power. So we can just use one radical with the 4 here, but then both things inside are cubed. So you must make it x cubed, y cubed. It would be easy to forget and make it x, y cubed and not have that with both of them. Example 11 here, the exponent is 2/3. Now there's not parentheses. So hopefully you'll see the difference between 10, where the parentheses is showing you that both parts are raised to the 3/4 power. Where in this case, the 5 is not raised to the 2/3 power, only x is. So the 5 stays separate out here. We put the x inside, raised to the second power again because the numerator becomes the exponent, and the denominator becomes the index. 12. So now again highlighting, we have parentheses. Both things are raised to the 2/3 power. So the 3 becomes the index. I'm saving myself some time here. Instead of writing 5 squared and simplifying it, I'm just immediately going, wait, 5 to the second power is 5 times 5, and that's 25. And then, of course, x also becomes to the second power here. Alright, now having all sorts of things going on, if we've got a 7 times 11 there, well that's like 7 times 11 has always been, it's 77. And again, neither one of them is raised to the exponential power here. Because the denominators are the same, I can just use one radical and put the 5 as the index, and then move the x and the y inside the radical to the power of 3 and the power of 2. 14, again, now this 7 is raised to the 2/3 power, so when I take the 3 and put it as my index, I'm then going to raise 7 to the second power, which is 49, x to the second. And then the square root, so I don't need to write the 2 there. And 11y to the first power is just 11y. All right, these next set of problems right here, these 4, 15 through 18, are going to show you what to do if you have an improper fraction as your exponent. And there's two methods here. You can choose whichever one you like. I'm fond of method 2 personally, but you may like method 1 a little bit better. The first is to do what we've been doing, which is to just rewrite it as a radical. So this is now the square root, the 2 is here, x to the 7th. And then we go back to our previous lesson where we're going to simplify the radical. So the largest perfect square that's inside of x to the 7th is x to the 6th, so that goes here, x goes there, and the square root of x to the 6th is x to the 3rd. Remember, because x to the 3rd times x to the 3rd would be x to the 6th. You basically divide the exponent by 2. Method 2, what we're going to do is make 7 halves into a mixed number. So the way we do this is say, well, 2 goes into 7 how many times? 3. What is our leftovers? From 2 times 3 is 6, from 7 is 1. This is 3.5. Once I have that, this is the equivalent of x to the 3rd times x to the 1/2. I would not require you to show this step. This is just so that you'll understand how this works. Remember, when we multiply with exponents, you add the exponents, and 3 plus 1/2 is 3.5. So I can break this apart this way and make it x cubed, and this becomes the square root of x. Perhaps a little confusing at first, but once you get the hang of it, you actually have less work that you have to show and can immediately get right to the answer. Show you another one. 22/3, so the 3 goes here, x to the 22nd power. So now we need the perfect power of 3. That is going to be our multiples of 3, the smallest, the biggest one that is less than 21. Less than 22, which is 21. Leaving us with 1x left over here. The cube root of x to the 21st power is x to the 7th, basically dividing the exponent by 3, the cube root of x. Method 2, we just look at this and say 3 goes into 22 how many times? 7. 3 times 7 is 21. 22 minus 21 is 1 left over. That is 7 and 1/3. This is x to the 7th, the cube root of x. Again, for my money, that's a lot more straightforward, a lot faster. I can get the answer a lot more quickly. These are not method 1, method 2 problems now. Now we're looking at what to do if we have negative exponents. So when I have a negative exponent here, I have to drop down this into the denominator, and that becomes positive. So now we're going to need to rationalize this. I'm going to go ahead and write it in radical form, the square root of x, and think to myself, what do I need to multiply the square root of x by? Well, by itself, to get it to be x squared. The square root of x squared is x, and on top we get the square root of x. Hopefully you've done the previous lessons, and this should be something you can handle, because this is what we did rationalizing exponents in the previous lesson. The next one, we've got x to the negative 2/3. Again, I drop it down into the denominator. I rewrite it as in radical form. Now, because this is x squared, I need to multiply this just by x to get it to be x cubed. Once it's x cubed, the cube root of x squared times x is going to be the cube root of x cubed, which becomes x. This is where you must make sure you don't just multiply by x squared, going back to the days when we first learned to rationalize, where we could always just multiply by what was right down here. Now we have to think about it a little bit. We're looking for a cube root. If I don't want to multiply by x squared, I'd get x to the 4th power, which is not a cube root. All right, 21. Again, I write it in the denominator here. I have the square root of x to the 5th. This case, again, because this is a square root, if I can just get this to be a multiple of 2, I will be able to take the square root. So I'm going to multiply by the square root of x. Not the square root of x to the 5th. That would give me x to the 10th. It wouldn't be wrong, but up here I would have then an x to the 5th that would need to be simplified. That would be more work. So just the square root of x will get me the square root of x to the 6th, and that's x to the 3rd. 22, now we're going to rewrite it in the denominator. It's just a square root, so I just need this to be even, so I can just multiply by the square root of x, get x to the 4th, and the square root of x to the 4th is x squared. All right, I'm going to continue this in the next notes in part 2. I hope it goes well for you.